Okay, so this is the Law of Cosines story problems worksheet. I'm just going to do problems 1 through 3. So in this problem, we get a side-side-side triangle, so we can use law of cosines to figure out at least one angle measure, so we can use law of sines to find the angle in which we can find our bearing using. So I'm going to use this version of the law of cosines, and I labeled all my sides and angles so I just can keep myself organized. So when you plug these numbers in, according to which side they go on, and you square 295, you get this number, and I guess I just copied it here. So basically what this all simplifies down to is you can use the inverse of cosine. Once you divide these numbers over here, you get 0.992, and it goes on a little ways. But when you put that in your calculator, you get the angle 7 degrees, or 7.21 degrees. And then that angle corresponds with A. So it's, now we can use law of sines to figure out the angle from the Bahamas back up to Maine. So basically this bearing right here, this triangle isn't drawn to scale, so it's a little hard to see. But you can use the A side and the sine of the A angle, which we just found. And then let's do sine B, because that will help us find our bearing. And then the corresponding side to that is 2,350. And once you multiply those across, you get 294.94 and 295 times the sine of B. So once you divide 295 over, you get 0.9997, goes up all the way. But once you put that back into your calculator, you get 88.84. And now with that number that we just found, you subtract it from 90 to find the bearing. And so that would give you 1.16 degrees is the bearing. Okay, so for the next problem, you have to find this distance across the lake from basically this angle and then those distances. So since this is a 180 degree line, it's just flat. That means 180 minus 110 is 70 degrees. So we can use that in our equation right over here. And I also labeled my angles and sides just to keep myself organized again. So, and I replaced A with X since it's X in the problem. But once you plug everything in, it'll look something like this. And once you multiply and everything simplifies down, you'll get these two numbers. Oh, I guess I skipped a step here. But once you multiply this cosine of 70 by these two, then you get this number. And then once you subtract those two, you get 87,675.73504. And then you have to square root both sides since it's an x squared. And once you square root both sides, you're just left with x, and the square root of the 87,000 number is 295. 96.1. So that gives you the length of the lake. So that is the answer. So for this last one, I'm going to use the same equation that I've been using for law of cosines. And it's just like the last problem where you'll end up square rooting the distance that you're going to find. So these two distances right here represent where the planes are at 11:30, how far apart they'll be. So it gives you the bearing of 5 degrees to the northwest and 67 degrees to the northeast, and that just represents the airport that they start at. So since that's on a 180-degree line, you just subtract both of those from 180, you get 108 degrees. Whoa, sorry. Camera almost fell over. Okay. So that will be... Sorry, I'm trying to hold my camera up now because it just fell over. That's, goodness, okay, sorry. It's 108 degrees. Just, yeah. Okay, so once you plug everything in with the corresponding sides, it'll look something like this. Okay. And then once you multiply this side together, you'll end up with a negative number, so this turns into a plus sign once you are finished multiplying. And then when you add these two numbers together, you get 600,737.156. And then again, because the a is squared, you have to square root both sides. And for that final distance, you end up with 775.07. So that's how far apart. I guess that would be miles. Be 775.07 miles.